Today we're going to talk about exponential functions, mostly graphs of exponential functions and identifying transformations of exponential functions, which of course we've done before. So let's look at the graph of f of x equals a to the x. Now there are two possibilities here. And the first possibility is that a is greater than 1. And if a is greater than 1, then our graph is going to look like this. It's going to start out low and then quickly go up. It always goes through the point here. That is the point 0, 1. That's what. So the graph is above the x-axis, completely above the x-axis. It's always increasing, and as x approaches negative infinity, y approaches 0. That's a key idea later on, especially when you get into calculus. Now the second possibility here is that a is between 0 and 1. A is never negative. You're not going to have a negative base. Okay? You're not going to have a negative base. But if you have a between 0 and 1, like a half or 0.5, 0.25, then the graph's going to kind of be a mirror image here, and it's going to do the same thing. And it's still going to go through that point 0, 1. It's still in the graph. And this graph is also above the x-axis. This one is always decreasing, and as x gets closer to positive infinity, y gets closer to 0. Okay. That is exponential growth. This is growth, and this is decay. There are lots of uses of those and applications of those, and which we'll deal with in the next section as we move on. Okay, the next part here is a little graphing exploration you can do if you want to use Desmos online, or if you want to use your graphing calculator, and you can do that, and I'll let you do that, and you can answer those questions for yourself. Okay. Let's go on. There's another graphing exploration on the next page here. You can do there as well. Let's talk about transformations and things we learned back in chapter 2. We learned translations. We also learned about reflections, and we also learned about stretches and compressions. So in chapter 2 we learned, first of all, we work from the inside out. And we start when we start on the inside, the first thing we do is the negative, the multiply by a negative inside is a flip over the y-axis. The second thing we do is multiplying inside. And now there's more than one possibility. We have a is greater than 1. That's actually a compression of 1 over a, by 1 over a. If a is less than 1 but still positive, it'll always be positive. The negative is considered separate here. Then it's a stretch by 1 over a. Right? And 1 over a in this case will mean it's going to be greater than 1. Right? Then we work to adding on the inside or subtracting inside. And if it's positive, it moves to the left. If it's negative, it moves to the right. These are shifts. Okay. Our fourth thing was the negative on the outside, multiplying by -1, which flips it over the y-axis. The x-axis. Flips it over the x-axis. We already flipped it over the y. And then we have multiplying outside, which again, if a is greater than 1, this time a is greater than 1 is a stretch, and a is less than 1, between 0 and 1 is a compression. And 6, we do adding is a shift up, and subtracting is a shift down. And those are our 6 things in the order that we're supposed to do them. So let's look at the examples here. The graph of f of x equals 2 to the x is shown at the left. Describe the transformation from the graph of f to the graph of the function below. We can see the +3 is the change here. The +3 is the change. So, and it's on the inside. It's on the inside because we're working inside the exponent. That's on the inside of an exponential function. So if we're adding on the inside, that's going to move to the left. So this is a shift 3 units left. That would be the transformation. Let's look at B. And now we still have the +3, so there's still going to be that shift 3 units left, and that would come first because it's on the inside. And then we have the -4, which would also be a shift 4 units, and because it's subtracted, it's down. Okay. And there's a shift, there's a vertical shift in there and a horizontal shift in there, both. The next, horizontal stretches. So now we have the graph of 3 to the x. F of x equals 3 to the x power shown at the left. Describe the transformation from the graph to the graph of the function below. So now we have this 0.2. We're multiplying by 0.2. And multiplying, we know, is either a stretch or it's a compression. And because we're working on the inside, the small numbers do the opposite of what we'd expect them to do. This is going to be a stretch. It's going to be a horizontal stretch. Let me write that a little better here. Horizontal stretch by, and we have to take the reciprocal of this number, 0.2. The factor comes from 0.2, but 0.2 is 2 over 10. So if we flip that over, it's 10 over 2, which is 5. So this is a horizontal stretch by a factor of 5. You could leave it as 10 over 2 would be acceptable as well, but it's nice to reduce it when we can. Okay. Now next, it's going to be, it's between 0 and 1. It's positive, so we have a horizontal stretch again. By a factor of, and it would be 8 over 10, flip it over, it would be a 10 over 8. Horizontal stretch by 10 over 8. Now here, we have a negative, but there's no number in front, so it's not going to stretch it because the factor is 1, so it's not going to stretch it or compress it by anything. But the negative does have an effect. It's going to flip over the y-axis. And that's what the negative does. That's the only transformation, is the negative. And then D, we actually combine B and C into, put both of transformations in there. So you're going to flip over the y-axis first, and then you would do a horizontal stretch by 10 over 8. Good. Those are good vertical stretches. Again, we've done all this before. Okay, so f of x equals 3 to the negative 0.4x is shown at the left. Okay, now you have to be careful here when we're describing this transformation. Okay, this, we have that negative 0.4, but that is not a transformation this time because it was in the original function. We only looked at things that are different from the original function. So that multiplying by 4, this is different. But the negative 0.4 is not different, so that's not a transformation in this case. So we're multiplying by 4 on the outside. We know multiplying is a stretch or a compression. And on the outside, multiplying by 4 is a vertical stretch by 4, a factor of 4. Okay, and in B we actually have two transformations. The negative is going to make it flip over the x-axis, and then the 2 is going to be a vertical stretch by a factor of 2. So it's going to double in size. The height's going to double. It's going to double in size. All right. And so average. The last thing we have to talk about is average rate of change. Finding average rate of change. So if we have a function, if we want to find the average rate of change of the function from f of x equals x3 to the x as x goes from 1 to 4. Whenever we want to find the average rate of change, we're going to find the rate of change between the endpoints. So what happens at 1 and then f of 1. So f of 1, which is 1 times 3 to the first, which is just 3. So my first endpoint is 1, 3. And then 4, where I end up, and then f of 4, which is 4 times 3 to the fourth, which 3 to the fourth is 81, times 4 is 324. So the rate of change between the endpoints, and to find a rate of change, we just use the slope formula. So we're just going to take the slope between those 2 points, and that is our average rate of change. So that would be 324 minus 3 over 4 minus 1, which is 321 divided by 3, which equals 107. So the average rate of change is 107 in this particular case.